Welcome to Next Gen Manufacturing. Today, we're going to look at a totally revolutionary class of materials that could change, well, everything. Plastics that are literally designed to disappear.
You know, plastics are a modern marvel, right? They're in everything from the medical devices that save our lives to the cars we drive. And their success really comes down to one simple fact: they last forever. But that exact strength, that durability, that's become their greatest curse, leaving us with a legacy of waste that will outlive all of us. So that is the game-changing question. And the answer, it turns out, lies in this fascinating field of material science called biodegradable polymers. Now, this isn't just about getting better at recycling. This is about fundamentally rethinking the materials we use from the very, very beginning. Okay, let's dive into this.
So, what does biodegradable actually mean? I mean, really, it's not magic, and it's definitely not about plastic just crumbling into dust. It's a very specific biological process, and honestly, understanding this is the key to this whole manufacturing revolution.
Okay, so think of it like this. It's basically nature's own recycling program. You've got microorganisms, bacteria and fungi, and they are the planet's cleanup crew. So the entire goal of next-gen bioplastics is to create materials that this crew recognizes as food, breaking them down into simple, harmless stuff that just gets reabsorbed by the ecosystem.
What's really cool here is that it's not a single event. It's a two-step process. First, you have biofragmentation. The material gets broken up into these tiny, bite-sized pieces. This just massively increases the surface area, which sets the stage for step 2, bioassimilation. And that's where the microorganisms actually digest those fragments. So it's kind of like a 1-2 punch of disassembly and digestion.
So where do we even get the building blocks for these new materials? Well, the first place scientists looked wasn't some high-tech lab, but to the greatest polymer factory of all, nature itself.
I mean, think about it. Living systems have been making their own advanced polymers for billions of years. We're talking about starch from corn, chitin from shrimp shells, which has even been used to make a biodegradable anti-graffiti coating. How cool is that? And even PHAs, which are basically polyesters that some bacteria make to store energy. In fact, scientists have even genetically engineered potatoes to produce a type of this bioplastic right inside their cells. Wild.
And this table just brilliantly illustrates the trade-offs. If you compare a starch-based plastic to the traditional ones, you see differences in things like strength and density. Starch plastic isn't water-resistant, which is a big deal. But look at that one crucial row: biodegradable. For the right application, that single word, yes, changes the entire game.
But just harnessing nature? That's only the start. The real next frontier in manufacturing is taking these natural ingredients and using advanced chemistry to build them into high-performance polymers that can actually compete with and sometimes even outperform their fossil fuel-based cousins. And the most famous example of this has got to be PLA, or polylactide. It is just a masterpiece of biotechnology. You start with something like corn, you ferment its sugars to create lactic acid. Yep, the same stuff that makes your muscles sore after a workout. And then you link those molecules into these long chains, creating a clear, rigid, and compostable plastic.
And what's so crucial here is the amount of control this gives manufacturers. By just tweaking the chemistry, say using a pure L form of lactic acid or a mix, they can create PLA with totally different properties. So, LPLA is tough, great for durable stuff, but the DLPLA is clear and brittle, perfect for things like disposable cups or even medical implants. We're talking about manufacturing on a molecular level. It's incredible.
And the innovation just doesn't stop there. The real cutting-edge stuff is happening in creating new alloys and composites. Scientists are blending different types of bioplastics together to get the best properties of each one, or reinforcing them with natural fibers like hemp or knif to create materials that are both biodegradable and incredibly strong.
Okay, this all sounds great in a lab, but where can you actually find these next-gen materials today? Well, you might be surprised. They're already here, and in some pretty high-tech and demanding applications.
Let's take your car, for instance. Toyota has developed interior door panels made from a composite of PLA and knaf fibers. Now, this material is lighter than the plastic it replaces, which helps improve fuel efficiency. And it's all derived from plants.
And in medicine, the impact is, well, it's profound. Surgeons are using screws, pins, and sutures made from these biopolymers that hold a bone together while it heals and then simply dissolve away. That means no need for a second surgery just to take them out.
For farmers, there are these biodegradable mulch films. They protect the crops all season long, and then at the end of the harvest, instead of having to be painstakingly collected and hauled off to a landfill, they can just be tilled directly back into the soil to decompose.
And even in your own kitchen, you'll start finding smart packaging made from bioplastics. They have these unique properties, like allowing some water vapor to pass through, which can actually keep produce fresh for longer. And the best part? The package can be composted right along with any leftover food scraps.
Now this all sounds like a perfect solution, doesn't it? But to really get a handle on this technology, we have to look at the challenges and the very specific conditions these materials need to actually work their magic.
So here's the reality check. Biodegradable does not mean disappears anywhere, not even close. Most of these plastics need the high heat and moisture of an industrial composting facility to break down effectively. They're not just going to vanish in a cold landfill or out in the ocean. And in fact, if you toss them into your regular recycling bin, you can actually contaminate the entire batch. So we need the right infrastructure for them to be a real solution.
And this quote from the source material really just sums it up perfectly. Biodegradability isn't some blanket solution to make everything disposable. It's a specific, engineered feature, a functional property, that you use intelligently in places where it offers a clear environmental or technical advantage.
Which leaves us with the big question for the future of manufacturing. Are these incredible disappearing materials the silver bullet for our plastic problem? Or are they a highly specialized, brilliant tool in a much larger toolbox we need to build a sustainable world? One thing is for sure. The way we make things is changing, one molecule at a time.